Today we are going to discuss the topic memory management and storage techniques in operating system. Memory management is the process of efficiently handling a computer's main memory, which is RAM. It allocates memory to programs, frees it when not needed, and ensures no process interferes with another. Key techniques includes paging, segmentation, and virtual memory, which help in running large applications smoothly and securely. Then is the key concepts. First one is memory hierarchy. Memory hierarchy refers to the structured arrangement of memory types in a computer system based on speed, cost, and size. Faster and more expensive memories are placed closer to the CPU, while slower, larger, and cheaper memories are farther away. Levels of memory includes first registers which are the smallest fastest memory inside the CPU. Then cache is cache memory is a very fast memory between CPU and RAM, and it has level 1, level 2, and level 3 cache. Then it is the main memory. Main memory is also known as RAM. It is a temporary storage for currently running programs. Then is the secondary storage, which includes hard disk SSDs used for long-term data storage. Then the trade-off is memory hierarchy involves speed, cost, and capacity trade-offs. Faster memory is more expensive and has less capacity. Then the next topic is virtual memory. Virtual memory allows a computer to use disk space as an extension of RAM, enabling the execution of large programs by giving an illusion of more memory than physically available. Then virtual versus physical memory. The virtual memory is the logical memory seen by the programs larger than actual RAM. The physical memory is the actual RAM installed in the system. Second one is address translation, converts virtual addresses to physical addresses using the memory management unit, which is MMU. This ensures programs can run without needing to know the actual physical memory layout. Then comes segmentation, divides the memory into variable size segments, for example, code, data, stack. Each segment has a base and limit supporting modular programming. Then is paging, divides memory into fixed size pages and pages meaning virtual and frames which meaning physical. Pages are mapped to frames, allowing non-contiguous allocation and efficient memory use. Then page replacement algorithms. First one is FIFO, which is the short for first in first out, which is simple but not optimal. Second one is LRU, which is the short form for least recently used, is optimal but costly. Third one is optimal theoretical benchmark page replacement. Fourth one is clock, which is the approximation of LRU with low overhead. Then memory allocation techniques. First one is contiguous. Memory is allocated in a single contiguous block, simple but leads to fragmentation, internal and external. For example, first fit, best fit, and worst fit. Second one is non-contiguous, which is a paging and segmentation. Memory is divided into fixed size pages and frames. It is paging, and the segmentation meaning memory is divided into variable sized segments based on logical divisions, for example, code, data. Then uh, dynamic partitioning. Memory is allocated in dynamically sized partitions based on process needs. The dynamic partitioning reduces fragmentation but may cause fragmentation over time. Then the disk storage management first, which is structure, scheduling, RAID levels, and file systems. Structures, which includes platters, tracks, sectors, and cylinders. Then scheduling involves FCFS, which means first come, first served. Then SSTF, scan, C-scan, look algorithms. Third one, RAID levels, which involves RAID 0, RAID 1, RAID 5, and RAID 10. Then the file systems, which involves directories, inodes, and metadata. Then the file system concepts. In file system concepts, first one is naming. Files are identified by unique names within a directory. The file name typically involves a base name and an extension. For example, the file name .txt, .txt meaning the file is a Word document. It might be made in Notepad. Second one is access. Files can be accessed in different ways, such as first one is the files can be accessed in two ways. First one is sequential access and the second one is direct access. Sequential access meaning data is accessed in a linear manner, which means one by one. Direct access meaning data can be accessed without sequential traversal. It can be directly accessed without going through sequential access. For example, random access file. Third one is mounting, the process of making a file system accessible to operating systems by associating it with a directory in the file system. It allows access to external storage devices like hard drives or network drives. Fourth one is journaling, a technique used in modern file systems to maintain data integrity. Changes are first recorded in a journal before being applied to the actual file system, helping to recover from crashes. Then it is solid state drives, SSDs. SSD, solid state drive, uses flash memories to store data, providing faster read or write speeds, lower power consumption, and higher durability. The difference between SSD and HDD, which is hard disk drives, is that one uses flash memory to store data and the other uses mechanical spinning disk or platters to read or write data. And HDD is slower than SSD and is more prone to physical damage but typically cheaper for higher storage capacities. Second one is flash memory, which involves NAND and NOR flash drives. Flash memory, a type of non-volatile memory used in SSDs, USB drivers, and memory cards. It stores data in memory cells made from floating gate transistors, offering fast access and durability without power. The third one is wear leveling, a technique used in SSDs to contribute data writes evenly across the memory cells. This prevents certain cells from wearing out prematurely, improving the lifespan of the SSD. And the real-world application of memory management is First in Linux, kernel memory allocation. Then in Windows, it is NTFS file system. Then in Mac OS is Mac OS, meaning Mac operating system, addresses space layout randomization, ASLR. In mobile OS, it is memory management in Android and iOS. Conclusion we can draw from this is that memory management and storage techniques play a crucial role in optimizing system performance. Memory hierarchy ensures efficient access by organizing memory into different levels with faster, smaller memories closer to the CPU. Virtual memory allows system to use disk space as an extension of RAM, supporting larger applications. Various memory allocation techniques like contiguous allocation, paging, and segmentation helps memory to manage memory effectively, balancing speed and resource usage. In file system, naming, access, mounting, and journaling ensures proper data organization and reliability. Finally, SSDs, with their faster speeds, low power consumption, and durability, outperform traditional HDDs, making them ideal for modern systems, while techniques like wear leveling ensures the longevity of SSDs. So that's it. Thank you.